To welcome you here in Brno. And on behalf of the organizing committee, I would like to start the opening of the 25th Text, Speech and Dialogue Conference. And for some official forward before the conference, I would ask a representative of the organizing body, the Faculty of Informatics, Masaryk University, the Vice Dean Petr Sojka, to tell you a few words, welcome you also here at the event.
Okay. Well, good morning. Welcome, everyone. It's really my great pleasure to meet you again in face-to-face in the role of Vice Dean of the faculty, and I would like to meet you in the name of organizing body, which is Natural Language Processing Center of Faculty of Informatics, Masaryk University. It's also my great pleasure to meet you as a frequent participant. As I remember, I have participated in almost 20 TSDs, at least at those 13 that have been held here in Brno. And also, it's my great pleasure to communicate with you in dialogue via multimodal communication, via text and speech, in dialogue, and communicate as a researcher in NLP again. Let me start with a short quiz. I will read you some quotation in one book, and it will be on your guess from whom I am citing from and which book I held in my hand. So, in the past decade, the greatly increased availability of millions of words of text in machine-readable form has been associated with a resurgence of empirical methods in natural language research. In particular, statistical methods of linguistic analysis have enjoyed a newfound popularity, with resultant benefits in machine translation, information retrieval, lexicography, message understanding, computer-assisted language learning, man-machine interfaces, and other fields. Research projects in computational text analysis continue to burgeon in innumerable research institutions throughout the world, leading to the development of practical applications in all the world's major languages. So what are your guesses? Who is the author? Which book I am holding in my hand?
Chris Money.
Pardon?
Chris Money.
No. And also which year this was said?
Are these the first TSD proceedings?
Yeah, great. You should be honored for that forever. And I will try to give you the prize. Yes, that's quarter century ago, quotation from the preface by Patrick Hanks. And most of this, I think, applies even today. We all know that machine translation triggered and deep models triggered the developments of human communication via text, dialogue, and speech in dialogues. And the topics is now boosting our lives and our everyday communication. So I'm looking forward to be part of this joy of communication via textual papers in the proceedings and via your speeches. I consider by this the conference open, And what will follow will also show the visible qualities of text, speech, and dialogue, as you will see. Thank you for coming, and enjoy.
Okay, so thanks for the first words. Now, before we start with the invited speech, we have something like well, cultural in opening, but it will not leave natural sciences. So I would like to invite here two performers from so-called Amazing Theatre of Physics, who will connect physics and our main topics, text, speech, and dialogue in interesting experiments.
Thank you.
Thank you so much. Okay, we put it somewhere. Yeah, maybe here. Maybe this will be the place. Okay.
Okay, perfect.
So, can we please blank the projector so we are not blind as usual? Hello and welcome. It is a strange position for us to be talking about text, speech, and dialogue from the perspective of physics. Because, well, we don't do that stuff in physics too much. But we tried. We tried to do some experiments on text, speech, and dialogue. Let's see what it brings to us.
And to know who is going to show you some experiments, this is Vojta.
This is Kaya.
And let's start with some text. If you have some reading, some amount of text, you read it, you have to carefully interpret it in context, and sometimes you have to read between the lines, of course. And we would like to help you with that with one physics hack. So, how do we do that? I have some example here, this paper, and to make it really simple, we have just two letters here, right? And
the comprehension of this text is the same as comprehension of physical formula for general public.
Yeah, okay. So, how to explore what's between these letters? If physicists want to do something cool, they use a liquid nitrogen.
Which is cool.
Literally cool. So let's do that. We have some here. So I will just pump it here a little bit.
You need help?
Yeah. No, that's fine. Thank you. Okay. So a little bit of the liquid nitrogen.
This is a Czech tradition to pump something out of keg on every occasion.
Okay. So now it goes in. We cool it a little bit. Perfect. And you can immediately see that there is something.
With meaning for all of us.
Yeah. And it's not hidden anymore. So perfect, we discovered that. But probably you do not believe us that every arbitrary piece of paper will do that. So how do we do this? We use some special pen with some special ink, and I can show you, maybe some of you use it or your kids do because it's usually quite popular. And it's this pen which is said to be erasable, but that's not true.
Yeah, in Czech we call them erasable pens. They are called friction pens, which is a better name for it, because this pen cannot be erased. It can be heated up. And when you heat it up, it will become transparent, which I can show you. I have this hair straightener, and I can erase the writing right away. And if you want the text to appear again, you just need to cool it, and the liquid nitrogen is a bit overkill. The freezer would suffice. So perhaps some of you are university teachers. Yes. Your students might use these pens. So when you are correcting their tests, put them in the freezer. So you will see what they messed up. So I can erase this text once again, so it is ready for the next year. We'll keep it, of course. And that brings us to the first aforementioned 2 lines, which is Roman number 2. So we might do the second experiment now. That's how we prepare. Yes, that's the level. Yes.
Okay. So the second experiment is connected to a dialogue, and again, physicists want to make things simple and do some approximations. So dialogue is basically just two people speaking, right?
Yeah.
So
The simplifying in physics, when you want to compute something with cows, for example, you assume the cow is a sphere, and it's in vacuum.
that's best, of course.
And then you do your calculation. So what is a dialogue for physicists? 2 sounds, just 2 sounds.
And we will have just a basic sound. I have 2 Bluetooth speakers, and I will place them in some distance here. And I will use a tone generator. It's just a simple app on my phone. And I have set a frequency of 600 hertz. And I can...
So this is the sound of pitchfork.
Yeah. And now I would like you to help us a little bit, to cooperate. So please, as you are sitting, try to move a little bit around your position and try to investigate whether the sound is changing. I mean the intensity of the sound. Is it somewhere louder or is it somewhere quieter? Yes, perfect. Thank you very much. So the second task is to try to decide whether you are in the maxima or the minima or somewhere in the middle. Try to check it with these other positions. And I would really ask you to stand up if you are in the maxima point, if you think so, please. Are there any people who are in Are there any people who are in maxima, or maybe you are just looking for it? Okay, okay, perfect. Thank you very much. And are there any people who are in minima, who almost do not hear that or not that loudly?
So the sound gets louder if you move either way.
Yeah. Are there any of you?
No.
It's
Not too dense population.
Yeah, but yes, thank you. Thank you very much. I will stop it because it's not that pleasant to hear.
Yeah, that's why they call them pitchfork. Because like a pitch and like a fork, it pierces through your ear.
Oh, yeah. So what you now experienced was sound interference. There are some maximas, some minimas, and if the density was high enough, we could see also the interference pattern. But at least you have the experience.
Yeah, sometimes even with 2 same sounds, the sounds meet in such phase shift that they cancel each other out, and this is something that happens in dialogue often.
On the other hand, it sometimes like resonate and it gets higher and bigger and louder.
Yeah, sometimes when 2 people talk, it gets louder and louder and louder.
Yeah.
So that's the physical explanation. And for the last part, we want to show you the sound, and this will be weird. If you want to see the sound, there are many ways to do it, and one is using laser. And we are doing physics show, so we have to use liquid nitrogen and lasers.
That's the bias.
Yeah, that's the bias, and it's also compulsory. So I have this laser, this one. This is laser. Let's see where it shines. Now it shines on the mirror, on this precisely made thing out of plastic tube and balloon. So you can see it's a highly scientific device. And into this opening you can shout. So it's very scientific. And when I do it,
I will move it a little bit. Try a little bit harder. Now. Well done. It's getting better.
So it moves. The balloon moves, and the mirror moves, and the spot on the screen moves as well. But me shouting is not a good source of sound. We have better. We have this phone, and this phone now plays music. It plays music. I don't know. Does it? Oh, yeah.
It is.
It's this music. And the music is played to these devices. There's a laser and two tiny motors with two tiny mirrors. And when the music is played into the motor, it shakes on one place, moving the mirror up and down again and again. And you can see what it does with the laser. So now we can see the music. We can make the music a touch louder. You can hear it also. And we can move one mirror or the other mirror. So we can move it vertically and horizontally. Because we have two ears, left and right, this has vertical and horizontal ear.
Okay, but you can see that it's just some chaos and
It's mess.
Yeah, there are no nice waves or something symmetrical, and physicists likes to have some symmetry. So let's move again a little bit, and we will use tone generators because these just precise. It's too
loud.
Now we could hear the music from these mirrors, but we do not want to do that. So we can use tone generator again and set some specific frequencies and have some specific sine waves. So what do we have here? We have 50 and 60. No, we have 60 and 60. Okay. So now we have both channels, I think.
Yeah, but I don't see the other one.
How is that?
How is it possible? I don't know.
Now we have the motion just in one direction and it looks like a line. But we would like to have two of them.
I would like to have the second one.
So I can try my phone if
Yeah.
you want. So I will change because I had 600 Hertz and it would be too much for this experiment. So I will change it to 60. And the other number could be,
Okay, now I have no signal.
let's say 50.
Okay.
Okay. Here
50
we
and
go.
50.
50 and 60.
Okay.
You know, 50 is for those who are from Europe, because we are familiar with the frequency, and 60 is for those who are from around the ocean or something like that. So, okay. And now I'm going to inside.
Yeah, I have your left, but I don't have your right. I guess it's the same problem as yeah. Maybe we shall switch the. Okay, I can. Yeah, there is a sine wave.
And now?
And now there is nothing.
No, it's just too.
Out of range. Yeah. Maybe this thing is messed
Okay.
up.
So sorry for this problem, but we can.
Do we have another in the table?
No.
This one.
No.
No. Okay. Okay. So let's not do that.
Mhm.
Let's do the other way. Let's use the voice. This is mono, so there's no left and right with the microphone. So the problem with the missing right is not as prominent with the microphone. And now I am talking. And now I'm talking to the both of the channels, as you can see, because it moves diagonally. That calms me down. So I can see that all the lasers are working, all the mirrors are working properly. But as you can see, this is a hot mess. Let's bring it down. Let's bring the, yeah, this is the horizontal. Let's bring the horizontal down. Now my voice moves the pointer only up and down. And for you to see how my voice looks like, I need to use Kaya as a trigger. She will be moving, maybe with your hand. It will be faster.
Yeah.
She will be moving the pointer on the screen, and you can see how the voice looks like when I speak.
Too loud.
Maybe I'm too loud. Okay, I can bring myself down
Yeah.
a bit.
Thank you.
So when I speak, it looks like this. Let's simplify it even more. Let's do just one letter.
And now this is nice sine wave, almost sine. That's not that nice.
It looks differently. the E looks different than A, and then E.
But these were vowels,
Yeah.
all of them.
I don't know how many of you have these consonants. We have S.
Which is quite mess.
We also have
Which is even worse.
and it looks differently because there are different sounds. They have to look differently. So this is how we speak, and this is how we listen to the speech and how we comprehend what is said, because the pattern is different, and because we can detect it with our ears. And I guess you will use your ears on this conference a lot. So we will leave you to the conference. Thank you for your attention, and perhaps use some lasers, have some fun.
Have a nice day, bye.